Hello and welcome to this presentation on the Cenozoic sediments of Singapore. My name is Tim Kearsey from the British Geological Survey, and I will be talking to you today about the youngest geological deposits in Singapore. I will be presenting the findings that are described in the new Singapore geology memoir. This has just recently been published, and which also includes the work from my colleague Dr. Stephen Chua at NTU University on the Kallang group, which he has recently published in the Journal of Asian Earth Sciences, and he collaborated with me on the writing of the Cenozoic section of the memoir. Okay, so this is the overall Singapore stratigraphy, which I'm sure you're now quite aware of. Today, we're really only going to be talking about this upper piece here. So most of this is dated as being Quaternary, so that's Pleistocene and Holocene, although some of the older units like the Bedok Formation and the Fort Canning Formation, the dating is a little bit more uncertain and they may go further back into the Neogene and maybe even older. Looking at the sort of regional story and looking at what's controlling these sediments, unlike the older sedimentary successions like the Jurong group, these sediments are, so the Cenozoic sediments are dominantly controlled by sea level change. So what is controlling where the sediments are being deposited is sea level change rather than the sort of tectonic story that we're seeing in some of the older rocks. We know that at times particularly in the Quaternary, sea level was much lower than it is today. And if you look at this, the diagram here on the right, you can see that sea level, so that the coastline was in these times much lower than it is today. It's much further away than it is today, and this was due to ice sheets on the northern hemisphere locking up huge amounts of seawater and dropping global sea level. Equally, when those ice sheets melt, we know that sea level got higher than it is today. So some of the low-lying areas of Singapore, such as the Kallang River Basin, were underwater and were basically marine. It's this story of sea level rising and falling quite dramatically over particularly the Quaternary that is really driving the sediments that we see in this part of the succession. Before we go much further, I'll just give you a little bit of background on our understanding of the Quaternary and how it has evolved with time. This is essentially a history of how we understand what we do, because it's subtly different from some of the older units. So the Cenozoic of Singapore was first subdivided in the Geology of the Republic of Singapore. So this is the map of memoirs published by Public Works Department and then DSTA in 2009. And this introduced units like the Old Alluvium and the Kallang Formation, and I broke up the Kallang Formation into several members. 2014, in work for BCA, for the Building Construction Authority, myself and Dr. Simon Price, identified that there was a quite high degree of interfingering in the Kallang group as part of the 3D modelling effort that we were involved in, and identified that there needed to be a lot more work done on that. Dr. Stephen Chua at NTU, as part of his PhD, has then refined that understanding and managed to date it, which is really, really critical. He's managed to get dates in the Kallang group to and actually tied what we're seeing in the Kallang group succession to the global story, the global eustatic glacier eustatic, sea level change. And this has led to the publication of the current stratigraphy, which is the paper in Asian Earth Sciences, the Journal of Asian Earth Sciences. So this is the old old map stratigraphy, again, which many of you should know very well. Let's say you have the Fort Canning boulder bed, as was the older alluvium, the lower and upper marine clay, and the alluvial littoral transitional reef members. The new stratigraphy may look slightly more intimidating, but I assure you, the two major changes we have made is, firstly, unfortunately, we had to change the names. This was just to make the stratigraphy compliant with international rules. You're not really supposed to use process names in the name of a geological unit. It's much better to use place names. But from your perspective as practitioners, the Jalan Basar Formation, for instance, is the alluvial member. We've just had to change the name. What we have also done is identified, as I say, the degree of interfingering, the degree where you see the same unit occurring at different stratigraphic levels in certain parts of Singapore, particularly in the Kallang and Kallang area. And we've also identified this unit called the Marina South member, which separates the Tanjau clay formation and the Rocha clay formation. And I'll come on to why this is a particularly significant unit in a bit. Looking at the depositional areas, and this is the new map, this shouldn't really surprise many of you. This is the depositional areas of the Cenozoic sediments are very much the ones that hasn't really changed. The main point to make is that the sequence is much more continuous, closer to the coasts. As you go inland, basically go up on it's only really present up river valleys. So again, this shouldn't be anything new, but it's just to make that point that the understanding hasn't changed that much. So now I'm going to start from the oldest, or what we think is the oldest geological unit in the Cenozoic succession, the Fort Canning Formation, and just walk you through some of the major findings with regards to these units, and particularly some of the more trying to put these geological units in their broader context and understand how they were deposited. So the Fort Canning Formation, as many of you know, is consisted of boulders of fresh sandstone or quartzite set in a matrix of hard silty clay. It does just about outcrop on our map, and it is shown on the new map. We're capping a little bit just at the surface in some places near Fort Canning. Its age is uncertain. Oliver and Gupta dated the boulders that make up the Fort Canning boulder bed and identified that they are the age of the Kuzu Formation. So those boulders are from the Kuzu Formation, which actually underlies the Fort Canning Formation. We also know that the Fort Canning Formation is overlain by the Bedok and or the Kallang Formation. So that gives us a minimum age. So we know it is older than the Kallang and Bedok Formation, but younger than the Kuzu Formation. However, that does give you some of the Cretaceous and most of the Cenozoic when this deposit could have formed. Talking a little bit now about its origins, so Sherlaw in 1999 posited that this was a deposit forming on the edge of a fault scarp. You can see this little diagram in here. And actually, if we look, so this screen grab we see here is from the 3D geological model, where we've lifted off the Kallang group and the Bedok Formation to expose the Fort Canning Formation and its relationship with the underlying Kuzu Formation. 2 points to make here. Firstly, the Fort Canning Formation only, as we currently understand it, occurs where there is Kuzu Formation below it. So that almost limits where we're likely to find it, although there might be some places elsewhere it might be buried much deeper. And also you can see, yes, it is sitting on the edge of a scarp. So if we look at this, so this top surface here, this is the surface that the Fort Canning Formation was deposited on. And yes, it appears to occur on the edge of this scarp. Now, there's a bit of question here. Is this the fault scarp that Shirlaw describes? That is possible. The other thing that is also potentially possible is that this is just the erosional limit of the overlying Bedok formation. That is to say, the Fort Canning formation was much more laterally extensive in the past, but the Bedok formation has eroded most of it and only preserved it at the limits of its erosional profile. Again, we don't know. I think that unfortunately we can't really add that much more to which of these two hypotheses is most likely, but it does seem to be associated with a scarp or an erosional limit of the Bedok, and it occurs, from what we know, only where the Kuzu formation underlies it. Okay, let's move on to the Bedok formation. So the Bedok formation, as I say, formerly called the Older Alluvium, or the Old Alluvium, or the Older Alluvium, depending on which literature you read. Its average thickness is about 50 meters, which is pretty significant for a fluvial succession, which is what we think it was. However, in some places it can occur nearly 200 meters below sea level, which is intriguing. It's an extremely variable thickness. And it's not very well constrained. Stephen posits in his paper that it might be the upper part of the Bedok formation is possibly early Pleistocene in age, but then whether it is a single continuous unit or several units representing a much longer period of geological time, we don't know. Again, this is probably one of the most mysterious units in Singapore still. We know that there are areas where it is significantly deeper. So if you can see on the map over here, this arrow is pointing to an occurrence of apparently the Bedok formation that is over 200 meters thick. And it's this, as I say, it's this northern area near Seletar. Now, if we read the borehole reports, this is defined as being more, or described as being more lithified than standard Bedok formation. It is possible that this might be a little bit of Kuzu formation that has been buried at depth and has not really been recognized, or it might be that there might be a new formation that has not yet been described, buried underneath the Bedok, and actually the Bedok is thinner than this. So some of this 200 meters in thickness is actually another previously undescribed formation. How do we think it formed? Well, again, this is it's generally thought that it's part of a river system, this large river system that's draining out to the west. Again, this is from Bird et al. And Cenozoic and various papers. So this, we would think that there was these river systems draining out to the west when sea level was much lower. However, locally in Singapore, because of this, that we do see it abutting up to this very sharp buried edge, which is coincident of where we think the Gneissian fault goes. So it might be the Gneissian fault scarp. What we don't know is whether the Gneissian fault scarp was active and it's basically produced accommodation space which the Bedok formation has then infilled, or whether it was just that that fault scarp was providing an erosional boundary because of the lithological differences of either side of it. The Bedok formation preferentially eroded one side of the fault than the other. We don't know. But there does seem to be an association with the Gneissian fault scarp in that part of Singapore. Okay, so finally I'm going to move on to sort of the Kallang group. Again, this is a little bit more, again, this is very much focusing on Stephen's work, and really sort of it's going to be summarizing his findings. So the Kallang group, as you all know, again, the map outcrop has really not changed that much. The only thing that probably might confuse you a little bit is that as you can see here, the stratigraphic column has got more complicated. That is again reflecting what we now know about how far the different units, the different formations in the Kallang group interfinger with each other. So let's start with what we think is the oldest. This is the Tanzhanru clay formation. Again, in boreholes, I'm sure you will know what this looks like. It's a nice, quite homogeneous clay and silts. And at the top, it has this this unit that new unit that we've defined as the Marina South member. Now, the Marina South member is a modified top to the Tanzhanru formation. It's probably a buried soil horizon, what we would refer to as a palaeosol, which represents quite a significant time gap in the succession. And I'll come on to why this is specifically important in a couple of slides. But it is a unit that we can trace through a large area, and it's quite a diagnostic one to allow you to differentiate the Tanzhanru clay formation from the overlying Rochor claw formation, where the two are on top of each other. The Rochor clay formation, again, from core, it can have different aspects. So it can be quite shell rich, and in other cases it can be very clay rich, and again is very much confined to the low-lying areas of Singapore. As you step inland to that, you get the Kranji formation, which previously might have been called the transitional member. And again, Stephen's work has kind of identified that this is probably represents a mangrove swamp. And a lot of the organic material we see in this unit is essentially plant debris that has been preserved in that swamp, in these creeks and river systems. Then over the top of that is the Jalan Besar. Unfortunately, I don't have a photo of a section through that, but again, it's the yellow area. It's the yellow in here. We do find channels of it in some of the more marine successions, and it also interfingers between the Kranji formation. But as you said, as you go further inshore, it becomes dominant. So inland, you will only ever find the Jalan Besar. And then finally, we have the Semakau and Tekong formations. These are raised beach deposits and reef deposits. The Tekong formation consists of fine to coarse sands. It's generally found in terraces about 3 to 5 meters above sea level. The Semakau is predominantly dominated by coral material and calcareous sands, and is found around the islands or on the flat top shoals and associated former islands. These units have been significantly affected by the land reclamation that's gone on around Singapore and the other engineering works that happened on the coast, such as the airport. So they might not be extensive now, so they're almost certainly a lot more patchy than they have been in the past. The origin of this quite complicated story is, as I said, this sea level change, and this is Stephen's work. So he's managed to. This is a work from Chua et al. 2020, and he's managed to date a lot of this, so he can tie it into the global sea level changes. And I say what you're seeing here is rising sea levels from a low, getting to high. This is when the marine clays are being deposited, which then in themselves then recede, and this is when you get desiccation. So this is the Marina South member, is essentially when the marine clays have suddenly become exposed at land surface because the sea has gone quite far away, we assume. And then sea level comes back again, floods back in, and you get the deposition of the Rochor clay formation, there's Holocene marine clays, and then as the sea level then starts to fall a little bit in the Holocene, you then start to see the coast starts to migrate to where it currently is today. To sort of show that in sort of a bit of a time series formed. So this is the stratigraphic column for the Kallang group, but now scaled by time. And what we can see here is that the Marina South member, that very thin palaeosol, that stiff clay palaeosol, actually represents most of the deposition, or the most of the time in the sequence. And the rest of the sequence is probably deposited relatively quickly. We don't really know what's going on inland. There might have been, we assume there were still river systems, but again, they're impossible to distinguish because it is essentially fluvial on fluvial on fluvial. So just sort of stepping back through time, so if we start with sort of the shoreline of today, and we think this is probably the current shoreline in Singapore is probably about 4,000 years ago, was when the current shoreline of Singapore, the sea came to its current resting position in Singapore. If we go back to about 10,000 years, this is again the Rothschild clay formation, and we can see that sea level may be as high as this, and so we've got sea level, basically Singapore being a much smaller island at that point in time, and therefore depositing these marine clays and the associated estuarine successions. So this is the Kranji formation in a lot of the low-lying areas of Singapore. Then if we go to the time of the Marina South member, actually at that point the sea was down here. It was right down in the Straits of Singapore. Again, this is Michael Bird's work, has kind of really worked sort of helped to define this. And essentially Singapore was a much bigger island at that point in time than it is today. Finally, just to sort of finish up, I wanted to pull out a few unknowns. So what do we not know still about the Cenozoic succession of Singapore? Well, the first one is there an older sedimentary unit or sedimentary formation buried beneath the Bedok formation in the north of the island? We don't know. And again, there's some interesting, tantalizing evidence, but again, it's still quite a big unknown. Again, back on one of the issues, one of the things we don't really understand about the Bedok is whether the faults were still active at that time, and so did we have active faults controlling the sedimentary patterns of the Bedok, or is the Bedok just purely reacting to pre-existing faults and structures in the landscape? And also, and again, I think this is something that Stephen is currently working on, is there occurrences of these things like the Tanjung clay and the Rothschild clay formations elsewhere in the island? His work was very much focused on the Kallang River Delta Basin, so the downtown area of Singapore, really. But elsewhere in Singapore, we might be seeing very similar successions. Again, I think this is work he's currently doing as part of his postdoc. So just sort of summarize and to pull up some key points. So the lithostratigraphic units in the Cenozoic in Singapore have not really changed. We haven't really completely redefined them, but the names have had to change to make them internationally compliant. We now understand a lot more about the method, timing, and formation of the units. And this really helps us to understand and predict where they're likely to occur in the subsurface. We realise there's a much higher degree of interfingering than I don't think anyone really previously understood. And again, it's the fantastic borehole data set that has been, many of you must have contributed to, which has allowed us to really understand this. And again, the understanding here is that there is an awful lot more interfingering. The units occur at multiple, so the formations occur at multiple depths within the same location. And sort of finally, the Bedok formation really still remains probably one of the poorest understood units in Singapore. Again, suggestions that it might have concealed units or subcrop occurrences of the Kuzu buried beneath it. Thank you for listening. If you have any questions, please could you place them in the Zoom chat, and we will collate them and answer them on the 24th of November in the Q&A. Thank you very much.